All right, today we're diving into one of the most incredible projects happening in emergency medicine, DARPA's Moonshot mission to build an AI medic.
So, picture this. Disaster strikes. It's chaos. You've got dozens, maybe hundreds of injured people. And in that moment, the biggest threat isn't just the wounds, it's the clock. Every single second counts.
You know, medics have a term for this. They call it the golden hour. The idea is simple, and it's absolutely critical. If you can get a trauma patient the care they need within 60 minutes, their chances of survival go way, way up. Miss that window, and the odds get worse with every tick of the clock.
Okay, but here's the problem. The golden hour works perfectly, until the scale of the disaster just completely overwhelms you. What do you do when you have 100 casualties for every one medic? How can a single person possibly make a difference against those odds?
This is where the old way of doing things really hits a wall. So let's take a look at how triage, the process of sorting patients by priority, is actually done on the ground right now.
So this is the manual, the standard system. It's called START, and it's literally a checklist a medic has to run through for every single victim, one by one by one. They shout, "Can you walk?" to find the least injured. Then for everyone else, they have to physically check their breathing, check their pulse, check if they're coherent. It works, for sure, but it creates this massive bottleneck. It's just tragically slow when you're facing a sea of victims.
And when you're up against a problem that just doesn't scale, you need a solution that's pretty radical. And that, of course, is where DARPA comes in. They're trying to completely reinvent the process.
Their whole strategy is broken down into two parts. First up is primary triage. This is where you send in the robots. Drones in the air, rovers on the ground. They sweep the danger zone, finding and assessing victims all on their own. And then comes secondary triage. This is where it gets kind of sci-fi. AI takes over and starts predicting the future, looking at data to figure out which patients are going to need life-saving care hours down the road.
And if you want to know why DARPA is so laser-focused on this time problem, just look at this data. This isn't a theory. During the war in Afghanistan, the military got really strict about enforcing that golden hour rule for wounded soldiers. And look what happened. The killed-in-action rate dropped from 16% to just under 10%. That's a massive difference. It's proof that saving time literally saves lives.
And that brings us to the big goal here. We're not talking about a tiny improvement. The whole point of the DARPA Triage Challenge is to develop tech that can boost survival rates in these huge incidents by more than 30%. Just let that sink in. That is an absolutely world-changing number.
Okay, so let's get into the nitty-gritty. How does this stuff actually work? We'll start with primary triage, the autonomous eyes on the scene.
What's so amazing is that these machines have senses that are frankly superhuman. LiDAR scans the environment to build a perfect 3D map so they don't get stuck. Thermal cameras can spot a person's body heat right through thick smoke or total darkness. They've got cameras that can see the tiny rise and fall of a chest to measure breathing from 50 feet away, and even acoustic sensors that can zero in on a faint cry for help.
So what do you get when you put all of that together? Well, you get a survivor map. The AI takes all that data from all those different sensors and creates this live, high-precision map. It hands a medic a tablet that basically says, okay, forget searching, go here first. This person is your #1 priority, and here are their vital signs. It completely changes the game.
But like we said, finding the patients is just one piece of the puzzle. Now let's talk about the second piece, which is, honestly, the most revolutionary part, an AI that acts like a crystal ball.
This quote from DARPA just hits the nail on the head. It's one thing to see a person with an obvious, catastrophic injury, but the really tricky part? It's the person who looks fine on the outside, but is slowly bleeding internally and is going to crash in an hour or two.
And that's exactly where this AI crystal ball shines. By using simple, non-invasive sensors, the system is constantly streaming physiological data, heart rate, oxygen, you name it. Its machine learning models analyze those patterns to see what's coming. It can flag a patient and basically tell a medic, hey, pay attention to this person. There's a 90% chance they're going to need emergency surgery in the next 2 hours. It's about getting ahead of the problem.
So just to quickly put it all together, you have primary triage, which uses drones and robots with things like computer vision and mapping algorithms to find people. Then you have secondary triage, using wearable sensors and sophisticated machine learning to predict who's going to get sicker. Two totally different challenges, both being tackled with cutting-edge tech.
Now, it's easy to see how this technology started with military needs, but honestly, its biggest impact could be right here at home, in the civilian world.
I mean, think about the possibilities. Those robots navigating a battlefield could be redesigned as vine-like bots that can wiggle through the rubble of a collapsed building after an earthquake. The drones mapping a combat zone could be mapping a hurricane's destruction to get aid to the right place. And that predictive AI? Imagine that in a hospital ICU, giving nurses a heads up hours before a patient develops sepsis or goes into cardiac arrest. The potential is just huge.
But, of course, it's not as simple as just flipping a switch. Building this future means we have to tackle some really tough challenges and think hard about what this human-machine partnership should really look like.
You've got the technical hurdles, right? Building robots that can actually survive in a fire or a flood. But then you've got the ethical questions, which are maybe even harder. How do we make sure the AI is fair and doesn't have hidden biases? How do we make it explain why it's recommending one patient over another? And when a life is on the line, who's ultimately responsible for the decision, the medic or the machine?
And this is so important to understand. The goal here is not to replace human medics. Not at all. It's about creating a true partnership, a symbiosis. Let the machines do what they do best. Search huge areas, crunch massive amounts of data, see in the dark. That frees up the human medics to do what only they can do. Use their judgment, perform complex medical procedures, and, provide that human touch of compassionate care.
And that really brings us to the final and maybe the most profound question of all. Triage, at its very core, is about making the most difficult choice a person can make, often under the worst imaginable circumstances. As we start to hand over pieces of that decision to an algorithm, we have to realize we're not just programming a machine. We're trying to teach it our deepest values, and that right there might just be the biggest challenge of them all.